All right. Forces with friction. Problem number 9. Let's go ahead and actually draw the free body diagram. We're talking about the box. So the force diagram looks like this. We will have a tension, since he's pulling it with a string. This angle's 30 degrees. We have the weight of the box pointing down and the normal force pointing up. Remember that these are no longer congruent forces since we have this upward tension. And we're going to have friction opposing the motion of the box, like we talked about before in class. Now, in the vertical direction and the horizontal direction, we need to split this into components. So we're going to have a Tx and a Ty. Ty will be T sine theta. Tx will be T cosine theta. And now we are finally ready to set up some equations according to what it says. So it says write an equation for all the forces and components of force on the box in the vertical direction. So we're going to have Ty pointing up. We have Fn pointing up minus Fg pointing down. And they balance. We know they balance because we're moving at constant speed. And also the other thing is in the vertical direction, we don't leave the floor, just like we did before. Now it says get the normal force on the box. So let's go ahead and do that based on the numbers we have here. So we have Ty plus Fn minus Fg equals 0. And now we can put them to numbers. So this is 200 times the sine of 30 plus Fn minus Fg. Let's just remember it's a 50 kilogram box. So off to the side, Fg is 50 times 10 because that's m times g. So that's give me 50 newtons. So minus 50 equals 0. So we have 200 sine of 30. I'm going to use the unit circle to get a half plus Fn minus 50 equals 0. So we've got 100 plus Fn minus 50 equals 0. Fn plus 50 equals 0. So it would appear, if I had this right, that's a very strange angle. I'm getting the normal force is negative 50. And this is a weird number because what this means in real life is that the box would have to physically leave the ground. I don't know that I necessarily like that kind of a question. Here's why. Fg is 50 times 10, which is 500. Got it. So this is going to actually finish up just a little bit differently. This is actually going to work out to be Fn, okay, minus 400 equals 0. So when we simplify, Fn will end up being 400 newtons worth of force. That makes more sense. All right, now part C, it says write an equation for all the forces and components of force in the horizontal direction. Looking back at the box, we would write down Tx minus friction equals 0. One rule, always subtract friction in this class. So we have T cosine theta minus friction equals 0. That's going to be 200 times the cosine of 30 minus F equals 0. Continuing, we're going to end up getting 200 times 0.866 equals 0. So that's going to be 173.2 newtons equals our force of friction. Now it says calculate the size of the frictional force opposing the motion of the box. And what I realized is, sorry, got a little ahead of myself here. This is what we were getting at for this question. Sorry. All right, so that is part 5 on the exam.